Happens millions and millions and millions of times per second on networks. Yes?
I don't want to take up too much information or too much time from this, but I would just be curious to get your thoughts on it, because obviously you teach on it. But what do you think of this whole movement of taking what's in the ASIC from the silicon level and putting it into the software level? And
I think it's only a natural progression for certain things to happen this way. I really do. There's certain things that can happen with the power of processing. And again, it only has to happen. Think about it. The first router was what? PC. It was software. It was a PC. It was a PC. It's all it was. But what happened is because networks grew so much and everything, we had to do something in chips because we're doing so much traffic through them. But with the evolution, with multiple cores and all this processing and all this multiple threading and all this that we can do now, yeah, you're going to move some of this stuff back into the SDN, software-defined networking. Absolutely.
I guess my question was a little bit more, I've heard it sort of being called as that could be really detrimental to Cisco.
Absolutely could be detrimental to Cisco in a lot of ways. Do I think it's available today? Absolutely not. I think in certain areas you're going to be able to do this, but there's going to be certain areas that you'll never, servers cannot do this. They will bog down immediately. So let's talk about real-time media. Conversion of traditional telephony or video, transcoding it and all this, that, and the other on a large scale or a normal scale. Probably not going to happen. We're always going to have ASICs. It's going to be a slow migration to this. Cisco's already defined, we've developed our own software routers. Our next generation of router, our next generation of ISR, it's not going to be called an ISR, but it's going to be a software-defined router. It's going to have less capabilities than our ISR G2s. Why? Because you can't do as much yet in that. So, will it? Maybe, maybe not. I don't think there's a server capable of pumping all this stuff in and keeping up with all this and the VLANs and stuff yet. It's going to take a long time for this. But in smaller blocks and everything, absolutely. It's just normal progression, And Cisco's, there are companies who are, that's all they do. Well, Cisco knows that, we don't want to kill ourselves before we have to, right? And there's, we don't want to compromise one product line from another product line and all this. But we've already got it. Matter of fact, I was in Boston doing some work up there and walked in and they had this big thing and there was a guy there who's working on the SDN solution and I had a long conversation. He used words so big I couldn't even tell you what they were. But he was really good and he broke it down for me really well. But it's coming and we can't stop it. We can't stop, it's like a market, the market trends. If you think about certain market trends, when you hear collaboration is going to be going from $9 to $53 billion because of all these cool things that's going on. Did they put an asterisk by that saying only if Cisco participates? No. It's going to happen whether Cisco's there or not, so we've got to get in the game. Does it erode some of our value? Maybe, maybe not. It depends. There may be something that we can do to address that with our chip, our strengths. Yes, sir.
It's very basic, but
yeah.
Sorry. How, in the first time, this PC knows that she should communicate with the 10, 10, 10?
9? Oh, great question. So, how do we know what IP address we want to go to? So let me ask you this. How many people here have shopped and bought things online at Amazon? Anybody ever been to Cisco's IP? Is it Cisco.com? Yeah. What's their IP address? Yeah. Where's their IP? Huh?
The application shows the IP address.
Yeah.
For example, when I enter to the web page,
yeah.
the DNS gives you the IP address for
exactly. Remember I told you there was 3 things they had to give you with DHCP? Well, there's some other things we give you. Anybody ever heard of DNS, Domain Name Services, right? What's that? So you don't have to remember. We're really good at names. We're really bad at numbers. I'm kind of opposite, to be honest with you. I've got cousins, I can't remember their names, but I can remember their phone numbers. I'm serious. I've got 2 sisters. I can remember their phone numbers a lot of times better than I can remember a lot of their middle names.
Is that how you break them?
Yeah, but DNS is actually given here. So there's actually a DNS server. So if your application, think of your mail server. Your mail server might be mail.cisco.com. That's what we put in your application of Outlook. That's your server. Well, that's not an IP address. So when you hit Outlook, whoa, don't want to do that. You can laugh if I fall. Promise you, I won't get mad. Maybe I'll cry, break something, and as old as yeah. But think of it. As soon as you click that Outlook and it comes up, it looks in the client and says mail.cisco.com. Well, what IP address is that? Inside of Cisco, we've got an internal DNS server. We've got our own DNS servers that for all of our servers that goes to. So when it says mail.cisco.com and we say, oh, we want to send it to it, as it comes down here, we stop and say, wait a second, mail.cisco.com is not an IP address, dude. And we stop what we're doing and we go over here to our DNS, which is an application layer protocol, and say, go get me that IP address. So we stop what we're doing up here. DNS goes to this server and says, I need a conversion from mail.cisco.com to an IP address. That's how that works. We do it internally and we do it externally. So if you do mail.cisco.com, we'll go to our own DNS servers. If you do Cisco.com or Google or whatever, this server might go out to the internet somewhere and pull it from our service provider who's providing DNS services for the whole internet. What's the benefit of using a name versus and DNS versus IP addresses? Yeah, think about the configuration issues. Cisco's got 70,000 employees. If we put in every client one IP address for their mail, just one IP address, and all of a sudden we wanted to change that IP address for any reason, what would we have to do? We'd have to reconfigure 70,000 clients. But what if we just put a DNS in there and then we wanted to change it from 10.10.10.9 to 10.10.10.10? We could do it at a DNS server and it would automatically happen. That's kind of cool. Easier to roll applications out and change them on the network. Yeah. So DNS is another thing that you'll get inside of that DHCP. You get all this information from DHCP. A very powerful application, DHCP is. So now we know this person was on our network and we sent it and goes back and forth. Again, our switch keeps up with where you're located, physically located. Keeps up with that in its spreadsheet here. What if I wanted to talk to 11.11.11.5? Let's go through that. Change this. So we got data coming down. Let's say that's a printer. We want to print on somebody's printer over there. We go through and the printer is, again, printer dot, second floor dot cisco.com. Right? It's a printer on the second floor. We go through we say we want to print to that. Well, we have to do DNS resolution and it comes back and says it's 11.11.11.5. So we say, all right, we have data to go to it. We go 11.11.11.5. Let's put it in our little sheet down here. Are we on the same network? Absolutely not. Who do we have to go through now? We have to go through our router, our gateway. If you think about routers as being gateways, it's really kind of cool because they're the gateway to the rest of the world that you don't need to have to know about. Think about the many, many routers. You have one entry point to the entire internet. Millions and millions and millions of routes, millions of routers out there, millions and millions and millions and millions of locations out there, but all you have to have is one guy to talk to who gets it there for you. It's kind of cool how networking works with this router. In this case, you want to send to your router. So the rule is, if they're on your network, you talk directly to them. If not, you send it to your router. Well, all right. I'm going to send it to my router in a frame. oh, wait a second, my router is 10.10.10.1. What if I don't know my router's MAC address? I know he's on my network. What do I do? Yeah, I do an ARP. If I haven't talked to my router, in most operating systems, they let you remember the last 300 seconds worth of people you've talked to, their IP address and their MAC address. They got an ARP cache in there that you remember. Depends on the operating system, but by about 300 seconds, 5 minutes. But if you haven't talked to your router in 5 minutes, it times out and goes away. So the next time you want to use your router, you say, oh, I've got to send it to my default gateway, which is my router, and I don't know it. I just ARP. I do the same thing here. I ARP out. Instead of 10.10.10.9, it'll be 10.10.10.1, goes through here, and again, the router is apart. So let's say the router is MAC address R, and he's on port 16 of our switch. That goes everywhere. He's the only guy who answers back. He answers back and says, I'm MAC address R, from MAC address R, and I send it back, unicast. You can always get there. You can always get there through the router. So then I send my packet out to my printer that I'm sending. It goes out through the switch. The switch looks at it, says, oh, you're still sitting in seat number 4. You're going to that guy over there, runs across the fabric, sends it to this guy. Now, routers are kind of unique. God, I love routers, but let me kind of draw up what happens in a router. Because it doesn't matter if it's the biggest router in the world or the smallest router in the world. They all work about the same way. In this case, this router has got the 11.11.11 network on one side and the 10.10.10 network on the other side. Now, a router, yeah. Oh, it could certainly have more. It could have a lot more networks. This is just fundamentals of how they work. So let's just do this. So a router has 2 types of workers inside of it. For every network that they're connected to, I don't care if it's 2 or if it's 2 million, they're going to have a layer 2 guy. They're going to have a MAC address. Somebody who comes in and wears a shirt every day and says, I'm MAC address R. The layer 2 guy on that. He's part of that network, and he represents that router to that network. On this side, he's physically connected to another network. Guess what? He's going to have another layer 2 guy who works over here, and let's give him MAC address Q. MAC address Q. They work here, but they all work for this smart guy, the layer 3 guy. The layer 3 guy. He's a smart guy. So let's see how this works. So we have that frame coming in. Source is 10, 10, 10, 7 going to 11, 11, 11, 5. That's what we've got coming in. There's data inside of here, and there's a frame check sequence. This guy comes in. Here it comes in on Ethernet. He catches it. He checks the FCS. It's good. It came across the wire really well. Then he goes over here. Hey, it's from 10, 10, 10, 7 going to 11, 11, 11, 5. That's not, I don't know a lot about that. Right? I don't know a lot about that. So what's he do? He pushes it up to his layer 3 guy. This is layer 3 information, right? Inside of every frame is layer 3 information. This is inside of that. I'm sorry, I've screwed that up. MAC address A to MAC address R. There we go. Does that make sense? Better sense now? Make it gooder sense? On the frame, it's MAC addresses, right? And then it comes in. He pulls that in and says, that's good, and opens it up. He pulls out the packet. The packet that he pulls out of there says from 10, 10, 10, 5 to 11, or 10, 10, 7 to 11, 11, 11, 5. And this has got the data inside of it. Does that make sense? Frame comes in, he checks the reliability of the frame, looks at that and says, yes, it's a valid frame coming in. He opens it up. He's left with a packet. He doesn't know what to do with the packet. He's layer 2 guy. Not been to that school yet. They keep promising to send him to that class, but they haven't. But he knows there's a guy who knows all about this layers 3 stuff. He works up above me. Have you ever been in a hotel room and heard somebody at night? You ever heard that even at your own house, right? I can tell when Emily's mad. Her mom says something to her and she starts stomping upstairs. Well, what's he do? He just says, hey, layer 3 guy, you get paid more than me and you work up there and I know you got nice soft. They give you free drinks like they used to do at Cisco. They give us all this stuff. You handle this, big boy. So he pushes that packet up to him because he's a layer 3 guy. Packets are at layer 3. This guy carries around a little table of all his layer 3 information. It's called his routing table. His routing table. Every network that he knows about is in this table. Every way to get to every network is in this table according to the routing protocol we give him. Now he's sitting there and he goes, okay, little angry boy downstairs, I'll take care of this. So he takes this packet up and he looks at it. He says, okay, my routing table, it says all I need to do is give it to this guy and let him send it on that network. They're directly connected to me. So he carries it over and he drops it down to this guy and says, will you please send this to number 5 on your network? That's all we need to do. So the packet that you originally sent goes up here and back down here. Now this guy reaches over, grabs an envelope called a frame, and puts that packet inside of it. So now our packet's inside of our frame, and now he has to label it. Who's it from? The source. MAC address Q to number 5. I haven't talked to number 5 lately. What do I do? You ARP. You ARP. He yells down through, hey, number 5, I got something for you. He just ARPs out this way. ARP. This guy's is C. This guy comes back and says, hey, I'm MAC address C. He can say, okay, MAC address C. Well, M's terrible. And sends it out here. That's how a router works. I don't care how big they are. They do this every time. It's called process routing. It's what a router does. Yes?
I don't mean to bring this to a more complicated conversation, but I only wanted to know, what if they don't know in the routing table of the router where to...
Two things happen. Two things happen. There's a command in all routers called default route. Default route. And if it says this, if you don't know where it's at, just send it to this person and he'll get you there. And if you don't have that in this router, he'll throw it away. It'll never happen.
When a router's first configured, though, how does it know where the default...
It's got to be configured in it. It's got to be configured in it. Yeah.
That's part of the software.
Yeah. That's part of the software configuration of it. Absolutely. Yeah. So think about it. If I have a big network like Cisco's got, and if you go from the biggest office to the smallest office and everything, all the way down to the very end, so if I have, a lot of routers in here with a lot of different routes to different places and all this, that's great. But if I have a stub, what we call a stub router, at the end of the street, there's only one way for that guy to go. I don't even have to tell him where to send everything because he's only got one way in and out. That's why I don't have to put a big router there with a big bunch of routing tables. Put a stupid router in there. Routers don't have to know everything. Now these routers here might have hundreds if not thousands of routes in your big network, but at the end of your network, default route, send it out this way. That's it.
So the default will throw everything out.
Yeah, he says if I don't have a direct route to that, if I don't see a direct route to 11 network to here, everything else goes this way. If he does not have that default route in him, he just drops it. Says, I don't do anything. And you won't see anything. It'll never come back. You can't get there. Your application will time out. That's what will happen. Yeah. Does that make sense? Folks, this is not rocket science. People like to think that. Now, as you get into larger routing protocols and all this, that, and the other, yeah, it does get complicated. And if anybody's ever had a CCIE, I don't know how many people in here are CCIEs, but if you got your CCIE, you were good one day. You were really good one day. Because, man, that's a hard test. That's the only one that means anything to me. For all these certifications, the CCIE is by far the toughest thing in the world to do. But routing is not that hard. It does this over and over. This is all you need to know about routing from my perspective. You don't have to know about EIGRP. It's proprietary to Cisco. That's kind of cool. BGP is for the internet. It's got billions of routes in it. It's really a client-server application and stuff. But other than that, routers just do this all the time. They take incoming frames, unleash the packet, look at the packet, and decide where I'm going to put it. That's what they do. Now they'll either do that through process or through some kind of accelerated method that we'll talk about here in just a second. Does that make sense? Now, I have two different switches here. So think about this. If these people were on the same floor, real life example, in 1995, in Cary, North Carolina, there was a Catholic school, a Catholic church that was going to build a school. Going to build a school in there. And my wife and I had, I say she asked me to marry her, but I asked her. I begged, actually. But we decided to get married. And my wife's Catholic, I'm not. So we talked about, the religion thing and all this. You have to settle some of those things. And she said, I want to raise my children Catholic. And I said, that's fine as long as I get to show them my religion. I was a Baptist and still am a Baptist. And I said, we'll let them decide when they get old enough, they can decide which way they want to go. Doesn't matter to me, but that's the way I felt. She agreed to it. And she said, well, if we want to put them in Catholic school, it's going to cost money. And I said, well, that's one strike against it. Actually, that's 1 and 2 strikes against it. I said, but that's okay. I said, and she goes, and they really kind of want to look at you as, what you've done for the church. And I said, well, I'm not Catholic. And she says, well, I know that, but you could still do things and get your name out there and stuff if we want to do that. I said, okay, whatever. You still marry me, right? Okay, all right, let's keep going. And so they were building this school system, and they just came in, and they were going to do all electronic, computer-based learning and all this, that, and the other. So they were big buildings, big network and all this. And think about it, this was when the early switching days and all this. So they were going switch to the desktop, which was expensive and all that. And when I went over there I went over and found out that they had this networking architecture group that was working on all this stuff. So, of course, a bunch of geeks. What do you think I want to do? I want to go with it. Matter of fact, I've got 2 guys that have been friends ever since I met there. So geeks, come to do this. So I go there, and there's this one guy who was driving the committee, and he says, in these buildings that we have, on every floor of every building, we're going to have at least 3 different networks. And they said, we're going to have a switch put into every floor for nothing but the students. And then we're going to have a switch on every floor, nothing but the teachers. And then we're going to have a switch on every floor to just manage this network, external management network. And we're going to connect all of these up, and we're going to separate them by routers. And we're going to put this in there because, kids will work harder at cheating than they will actually learning. So we want to isolate these networks as much as we can. Now, I just came from Blue Cross and Blue Shield of North Carolina, and I knew more about switching than I ever cared to know because we just went fully switched there. Spent a lot of money in that. And I came into this second meeting of this group, and I said, that's pretty expensive, and I think we can get something better. What if we could buy one device like this, and we can have certain ports associated with the students, and certain ports associated with the teachers, and certain ports associated, and have different networks on the same switch? We could, get this, virtualize the switch. And the first guy raised his hand, little short guy. Never liked him. Don't ever want to see him again, actually. Didn't like him. Raised his hand. Security risk! Security risk! Well, think about it. It was a new technology, really, to him. And he had a legit, what do you think about it? It's riding on the same wire? How are we going to isolate that? Those little cheating students, they're going to figure out how to do that, to get around that. Is this secure? It's called VLAN technology. VLAN technology. It was new at the time. Did that save this group money? How does it save money? Less physical devices, right? Do we use that today? Do we use VLANs today? Every day. Give me a use of a VLAN today. How would we use VLANs in everything we do?
For voice network and
Yeah, voice. By default, on every Cisco switch, voice is in VLAN 200. You can change that if you want, but if it sees that's an Cisco IP phone, it's going to put it VLAN 200. You configure it right. Yeah, separate voice and data so we can do what we call QoS. What's another reason for VLAN? Wireless. And wireless, we might have to have multiple networks on that with our access points. Think about that access point. We want to have guest net. We want to have voice net. We want to have video net. We want to have Blizzard. We want to have all these different networks and everything. Guess what? Those are all different VLANs on there with different capabilities and different needs and restrictions. Yeah. What else? What else would we use VLANs for? Accounting by departments? Absolutely. How about security?
External connections.
Yeah. How about think about security. When you first connect up into a network, would we want to stop you? You know, we might know who you are, but what if you had one of those nice little diseases we call viruses on this? Right? We might want to check that and see if you got the right antivirus and all that. In today's world, this security thing we call 802.1x, there's a protocol called 802.1x that means that every device that connects up on a network has to have a login. You have to log it in some way, shape, or form. Cisco does something called network admissions control, which takes that a little bit further. We actually look on the device and see if you got your updated antivirus, if all the different things are on it. And if you bring this thing in and you haven't got the latest antivirus or you've turned it off, we're going to put you in a special VLAN called a remediation VLAN. Doesn't sound good, does it? Yeah, quarantine you. We'll put you in there. And if we think we can fix you, we can actually pop up a window on your screen and say, the network administrators have noticed that you have your antivirus turned off and you're a security risk. So if you turn it on, we might let you back in. If not, you can't go anywhere. We'll put you in a special VLAN. And here's how simple it is. Remember that spreadsheet? We just added a column. That's all we did. We just add a tag to you when you come in. It's called a VLAN. A VLAN tag. It's a VLAN tag. We tag your frame when it comes into the switch and we take it off when it goes out of the switch. A VLAN tag. So all of the engineers are in the engineering VLAN, which is associated with one IP network. All the salespeople are in a different VLAN, so associated with a different network. We can isolate that. We can do it by MAC address. We can do it by your login, which is the best way to do it. We could just do it by port. Early on, we just did it by port. Anybody plugs in here is in VLAN 4. Anybody plugs in here is VLAN 5. It's best to do it by your login. VLAN technology, virtualizing this. And it saves, instead of having 2 switches, I might be able to consolidate down to 1. Yes?
VLAN is a technology
Yeah.
that is included in some
All switches today.
all switches?
Yeah.
In all routers?
Yeah, yeah.
In all switches and routers? But why, there must be a threshold as to why that's less expensive, right, to use VLAN on a bigger switch than having 3 or 4 different ones.
Well, generally it's going to be your port count, right? Depending on your port count and the type of switch. Yeah, the amount of users and all this. The smallest switches that Cisco have, the 2900 support 1,000 VLANs. The larger switches support 4,000 VLANs. I mean, and I've ran into some big networks, and most switches, if they have 50 VLANs, you're in a really big network in one switch. 50 VLANs. That'd be your core switches.
So your school there had more than 1,000? That's what you're saying?
No. They only had 4. They ended up with 4 VLANs.
Why was it less expensive?
Well, it wasn't more expensive. It comes in the switch itself. Now, here's the rub. The switches that they wanted to buy, so here's we go back to this unique ASICs and stuff. Features such as this, at the time, if you had the standard inside of these switches, if you had that standard ASIC, and again, this became a standard relatively quickly, about 18 to 24 months, If you wanted to get VLAN technology on that switch and you had the standard ASICs on your switch, how did you get it? You went to your vendor and said, I want VLANs, and they said, well, you got to buy a new switch because you're going to have to swap out your ASIC. If you went to Cisco, who was building their own ASICs, and said, I wanted to have VLAN technology on this, what did they say? Well, actually, you've got SmartNet maintenance, do an iOS upgrade, and you'll get it. Would that be better? Yeah. Tomorrow's features on yesterday's hardware. That's the uniqueness of building your own ASICs. That's the uniqueness. Yeah. That's why ASICs are, the Nexus 5000, when they put out the Nexus 5000, they created unique ASICs for just a data center. That was one of their little bullet points that they came out with. They'd had to rewrap some ASICs and redo that so it would just handle the data center. Because data center was going to roll out some really cool technologies that were unique to data center that we'll talk about tomorrow. Does that make sense? VLANs are virtualization into switches. This is everybody uses it today. But this is why switching was a transformational technology back in the 90s. It got rid of hubs. Gave your networks a lot more bandwidth. Your applications needed that bandwidth. You didn't have all this slowdown when somebody printed and all this. And then you could start virtualizing and isolate all these. Isolate all these. What would be so now I may not have to have 2 physical switches. I could put one. What do you think is the next evolution inside of networking that happened in 96, 95, 96, 97? VLAN trunking. All right, so let's say that I have a bunch of VLANs in here, different color VLANs. Let me just put them in here. Let's say I have all these VLANs on this. What if I wanted to have the same VLANs here as the VLANs there? If I wanted to have the black if I had all these switches, I'd have to take the router out here. Put another switch up here. What if I had 2 switches that want to have the same VLANs on them? I'd have to, if I wanted black VLANs on here, I'd have to do this. If I wanted red VLANs up here, I'd have to do this. If I wanted blue VLANs up here, I'd have to do that. If say I had 48 ports on this switch, I needed 62 ports. I'd have to have 2 physical switches, but I want to have different VLAN, the same VLAN on each switch. I'd have to waste ports, 2 ports per VLAN. That's not good. Waste, because again, these ports, $400 a piece. There were $400 a piece for these ports in switching. Kind of expensive. What if, and again, this is where Cisco said, I can give you a unique port. Color didn't I use green? I did use green. What if I put a connection between here and I called that a VLAN trunk? A special connection between 2 switches that allows VLAN traffic, all VLAN traffic. So black VLAN could go across here, blue VLAN could go across here, and red VLAN could go across here. Would I save you ports? Yeah, I saved you 2 right there, which is almost $1,000, almost $1,000, almost $1,000. You certainly could. You certainly could. But what if I did this? Put 2 of them here and actually put them both together. Yeah. It's called ether channeling. Those were unique things that Cisco did before there was a standard to drive. And those 2 right there in the mid-90s, 96, 97, 98, gave Cisco probably 12 percentage points in the industry. Market share points. Because we were first to do it, because we designed our own ASICs, and we could come out with the technology, upgrade the switch without replacing the switch to give a customer this growth in their network. And then when the standard came out, you upgrade the iOS, you get the standard way of doing it. What's Cisco's market share in switching? 60, 62, it depends on how you divide it. The high-end switches, low-end switches. Some are just south of 70 for high-end switches and some are in the low 60s for low-end switches. Dominant player. Now, did they just get that last year? How long have we been #1 in switching? Many, many, many years through innovations like this. through innovations like this. Why? Because at the time this happened, the market transition was to add more applications that needed more bandwidth, so hubs wouldn't work, so you were going switched, but you wanted to maximize the use of those switches with many networks, virtualization. So Cisco came up with these technologies. This is all things that are, everybody knows about these now, but what I'm trying to get to is Cisco has driven this by doing this before the standard, and then when the standard comes back, adhering to the standard. You're going to hear customers say, and some of you who used to work for competitors, oh, Cisco's proprietary. They like to lock you in. Well, guess what? Cisco doesn't let the lack of a standard stop them from giving a feature. And when the standard comes out, we adhere to the standards. We do. We've driven more standards than anybody in the industry. Absolutely. But if there's something we need to do and there's no standard, we're not going to wait 24 months before everybody can do it. We're going to do it on the front end. Where do you want to sell that? You want to sell that when nobody else can do it. That's a differentiator. These were differentiators for Cisco that gave us that great market share. Like Power over Ethernet was. Like being able to do QoS was. To make voice run on a network really well. Those are the things that we do. Yes?
From the AT&T perspective today, there's existing legacy architectures like MGX that we sold years ago. We have since we deployed it, and it's a large part of AT&T's network today. We're no longer able to sell the hardware or anything else. We don't have a solution to migrate for next-gen MGX at this point.
You're talking about the mobility and all that? Oh, and Cisco does have a hole there. Right, they do.
So the question of it is when you have a situation where you are in a proprietary basis like we are today, because this is what I'm struggling with, is if you're in a proprietary situation and the product is no longer available for sale, and the customer still wants it, I mean, the network is viable.
Well, the network is their business, right? The service provider.
So they bought this and they have live customers on there. We're no longer able to support it, and we don't have a plan of record to migrate them to a next gen. What do we do to be able to protect Cisco's way from today moving forward?
Well, let me just say this. Cisco didn't just turn out yesterday and say, we're not going to support the MGX anymore.
No,
they've known that for 5 years. And there's probably been dialogue with that customer, especially AT&T, who up until 2 years ago was the largest customer Cisco had. And we're talking about billions of dollars in revenue from them. That's just, I'm sure Cisco's probably said, hey, here's what you probably need to go to. It might be a competitive product. It might have been. I mean, we don't sell radios, right? How many people in here do RAN networks? Do we sell radios? No, we don't. Closest we get to it's the ASR 5000, right? The provisioning of it and the services off of it. Yeah, that's been a complaint for customers for years. I'd love to give you more radio business, but you don't sell radios. You have to do the back end because Cisco just didn't see that as we don't want to get into towers and radios. So I don't know what the answer to that would be, but I can tell you that customer has known for many, many years that was going away.
I guess from that standpoint is there, from your vantage, knowing that situation specifically, and knowing the way that the different reliability situations have been built up over the year, is there a recommendation for support?
I'm sure the CSEs on that account, and a matter of fact, there's a guy in New York who works on that who's what we call a distinguished engineer, who's one of probably the top 3 people smart I've ever met in my life. And when I saw him, he just is amazing in a lot of ways. Great business, but I'm sure they've got proposals for them to do. I don't know what specifics about that. Again, I'm sure that Cisco has not let that customer know about this. I mean, we just didn't turn it.
So they definitely know about it. I guess my point of it was that in this particular situation where you've got routers and switches that have been
well, you have to understand. You have to understand. Service providers look at routing and switching totally different than enterprises. In an enterprise, we want to do as much as we can in a switch, and routers to a switching to a service provider is fan out. They're just replication. They don't want to do anything in switching. They want to do everything in routing. That's what they want to do. And that's their whole persona. It's all the value they think they get. Cisco's never tried to change that because, they were a bunch of geeks and they were router people. Really is what they were. And they've never grown out of that mentality. We sell them switching only for fan out so they can connect more users to a router. That's all we've ever done. Where in the enterprise, we want to put as much intelligence as we can on the switch port. As much as we can. That's what we want to do. Next evolution. What do you think we did next? We actually took this router and put it inside of that switch. So now you don't have to go all the way to a router. It's called layer 3 switching. Has anybody ever heard of layer 3 switching? Yeah, exactly. Cisco's been doing that since 1996. Since 1996. Cisco was one of the first people, again, all those acquisitions and everything. They put a blade in a big old blade in a big old switch that was a router that converted every port on that to a potential router port. And we could do what we call inter VLAN routing. Now, it changed the way this worked because if this is inside of a switch, I can do this at light speed in an ASIC. Where this router before might have done 70,000 packets per second of process routing through there, I make this a layer 3 switch, put it inside of a switch, do some really fancy things called Cisco Express Forwarding. And guess what? Now I'm doing, 1 million packets per second between VLANs. The switches we have today, the 3750 and all that, they do 12 million packets per second of switching between VLANs. Light speed. The cost of routing is insignificant in most cases for customers. What it allows you to do is start isolating networks, creating networks, isolating networks, but allow communications through networks. Easier on our switches. So the characteristics of a switch are going to be the number of ports, the capabilities. Is it layer 2 only? If it's layer 2 only, it can assign VLANs, but it can't route between them. If it's a layer 3 switch, you can assign VLANs and route between them. A layer 3 switch. What if I told you that there's a switch that you could buy? It's got 48 ports. Yes. So a layer 2 switch can assign VLANs, but it cannot allow traffic to go between the two. It's called routing. A layer 3 switch has got a router inside of it. It can assign VLANs and put traffic between the two. Yeah. We have a switch, a couple of models of switches, the 3560 and the 3750, which actually you can buy them as layer 2 switches, and then you can upgrade the software because we send them with a router inside of them. And if you upgrade the software, you can actually have a router inside there. And then if you want to do even really more cool stuff, we can actually upgrade it to do about anything you'd ever want to do except wash your dishes. So we'll look at those products and everything. So does that make sense? Switching is a fundamental thing at Cisco. We are very, very, very good at it. We're innovators in this space. Early on, this was innovation, just adding users and stuff. Where's the innovation today? MediaNet, EnergyWise, things that are really outside the norm because of the changes that have happened in there. That's the big things that are evolved today. Does that make sense for all that? So let's just, and so when we categorize the switches, and we'll look at these in just a second. When we categorize switches, we'll talk about them as layer 2 only, perhaps layer 3, where they would fit, access distribution core. Are they a standalone switch with a lot of ports, or are they a chassis-based switch? A chassis-based switch. So we'll look at this. What's a chassis-based switch? Anybody know what a chassis-based switch is? How would you describe a chassis-based switch? Sits in a chassis, yeah, exactly. Yeah, with blades. So I could draw it up here, but let me just show you. Let me show you. It's, a picture's worth 1,000 words, so here's a few million for you. So this is a Catalyst 4500 chassis switch. 4500 is one of our models that's going to be around for a while, so you're going to make a lot of money on these things, right? Notice that, first of all, I had one of these, earlier model of these, not this one, the 4510. I had a 4006 in my garage, in my lab. And Emily comes in from elementary school and says, "Are those speakers? Can I run my MP3 player through it?" No, they're not speakers, they're power supplies.
It does look like a stereo.
It kind of does, doesn't it? I mean, when you think of it. But these are the power supplies. Why do we have two? Redundancy. What's the number one thing that goes out of all electronic equipment? Power supply. Yep, it's always doing the work. So we got load balancing power supplies here. And again, depending on if you're doing power over Ethernet out these ports, it'd be a bigger power supply. So you can swap these things out. Now in a chassis-based switch, our chassis-based switches, we have supervisors. This is going to be the expensive card. When you look at the bill of materials, you'll find this one by looking at the big price tag. Okay, this. The supervisor runs the iOS, the smarts of the card. It's got all the brains, the iOS. It's got a lot of the hardware on it and all this, that, and the other. Different supervisors have different capabilities. Today, I think the Sup 7 is the premier supervisor we put in this, and it gives this switch the ability to do 860 gigabits of throughput per second and all this, that, and the other. But it's the smart. It's actually a Linux-based operating system that we've laid our iOS on. We've laid our iOS on Linux. So it's a Linux-based servers. Now, we can have two of these supervisors in here. Why would we want two? Yeah, redundancy again. Think about, and it's really cool, somebody messed with that. What if I wanted to do an upgrade? What if I said, "Hey, my network's running. How much downtime do you think your customer allows you to have?" Like 0, right? So what if you want to do an upgrade on your switch? "Oh, I got to go from one software load to another. Don't know if that one's going to work for me." On our switches, you can actually run one version of code on this and one version of code on that, just to test it out. And have no packet loss switching between the two. Yeah, non-stop forwarding on the boxes and all that. So again, addressing that the network's always available. Absolutely could do that. Phone calls still happen. So if I got a phone call going from here to here or wherever, and they're talking and we go from here to here in our software, it doesn't change a thing. It still works. You can order these cards, and again, these are called line cards that go in there. And for the 4500, this is a line card. It has gigabit Ethernet connections. You either can have fiber optics, SFP based, or you can have copper based, depending on what you want. We have so many different line cards, you wouldn't believe it, for these things. I mean, you can fill this thing up. And we'll talk about the size of the chassis and all this. This is what a chassis, so you order the outside, you order the power supplies, you order the supervisors, and then you can build whatever you want. Build whatever you want in. Well, believe me, we've over-engineered this. It's got fans on the side to do this, hot swappable fans. So if the fans ever go bad, they'll tell you they're bad if 1 or 2 or 3 of the fans go bad.
Is there any maintenance recommendation as to how often those fans need to be checked and go cleaned?
They'll actually keep themselves checked. They check themselves, and actually it'll shut itself down if these fans are not working.
Other vendors I know for a fact that the point of failure.
Yeah, oh, absolutely. Well, Cisco's, again, I think Cisco's got the bugs worked out, but again, if, there's several fans on here, and if one or two of the fans, they'll actually send out an SMP alarm saying, the fans are working, but 2 of them are not, and you probably need to replace that. And you can actually replace it while it's still in service. So, a lot of ways around that. But it is a concern for customers, absolutely, with networks. And again, different slots that you have. Now, has anybody ever heard of, Cisco's, we talk about, this changes and all this. This is probably the switch that you're going to probably move on with. But Cisco's had that Catalyst 6500 for years. Anybody ever heard of the Catalyst 6500? Yes, no, yeah. The Catalyst 6500 was Cisco's bread and butter switch starting in the late 90s. At one point, it was almost a $2 billion a quarter product line. A quarter. Think about that. $2 billion a quarter in one product line, that Catalyst 6500. Now it's been out there a long time. So Cisco's now got to worry about that. That was a core switch that we had. We need more bandwidth. It goes up to about 2 terabytes of throughput on that core switch. Customers are demanding more, so Cisco has to create the Nexus family of products. The Nexus is a data center switch that could actually run the core of an enterprise, and it goes up to 15 terabytes. So do you see Cisco's problem here? Do you want to slow down that $1.5–2 billion for this new product and all this? Really a tempting place. Boy, Juniper liked that, didn't they? Juniper loved to be able to go out there and say, now you got Nexus OS, a new operating system out there and all that. They had a lot of discussions about that. Actually, Nexus OS has been around for a lot longer than Juniper really stated. Nexus OS has been around since 2002, actually, and been running in a MDS 9500 in a fabric switch, so it should have been easily addressable for Cisco. But the Catalyst 6500 was a totally different architecture. This is a supervisor for a Catalyst 6500. This is a SOUP 720. See, notice the difference in size. Yeah. This blade, the SOUP, this guy is probably about $19,000 list price. This guy was closer to $35,000 list price when it first came out. So big difference, and in capabilities. These had daughter cards, layer 2 cards, layer 3 cards, and all this. This was, again, it's still the flagship product of Cisco and what it can do. But that's a chassis-based switch. So when we go through our products, we're going to say access distribution core. Is it a chassis? This might be in all your wiring closets. If a customer has a lot of users, they put 2 supervisors in here, a whole bunch of 48-port line cards in it, and it's an access switch. Might be the distribution switch for your customer. Might be the core switch for your customer, depending on their size. So this is a very multifaceted, depending on how you configure it yourself. And again, you configure it by putting the different models in. It'll support gigabit Ethernet, 10 gigabit Ethernet, 40 gig Ethernet today. We'll eventually support 100 gig. We'll eventually support 100 gig Ethernet.
I have just a silly question.
Yes?
Why the number of ports always 24 or 48? Why is it, for example, not 50 or 60?
It's the way they originally designed the ASICs, when you had the ASIC mesh and everything, the way they designed those ASICs, that's how it ended up being. And it's just always been that way. So.
It's based on binary most of the time.
Huh?
Number of bits that you reserve, or 8 bits or something, so it scales to 24
Yeah.
the way.
Well, it was also when they did the ASIC meshes for the original things, they could only string them out so much, I think. And that was probably based on binary, so yeah. But yeah, no 50-port switch. You'd think they'd do that. It'd be easier. We got 10 fingers. Let's do a multiplication of that.
It was done as a determinant of what the best cost-effective connectivity when designing an ASIC based on the size of the ASIC, the cost, and the complexity that would go in. That's actually how it got to be at least the standard around 16.
Yeah. So let's just go online, and you've all heard the term now. What we're going to do is we're going to move on to the next section.